The lesson outcome for this video is I can write the equation of a line given a graph. So in previous lessons we've learned to write the equation of a line from other information, but now we're going to look at a graph and be able to write the equation. And one thing I want you to think about here is that we could actually write the equation of this line in both forms. Okay, we could write it in slope-intercept form, or we can write it in point-slope form. So we are going to do both in this situation. Okay, so first of all, slope-intercept form is y equals mx plus b. We need to be getting used to that. And it's pretty easy to see that because slope is m and the y-intercept is b, so slope-intercept form. So we need to know the slope, and we also need to know the y-intercept to write it in this form. So our slope m from the graph and our b, y-intercept from the graph, can be found. B is right here. B is the y-intercept, so we can see that that is at 3 on the y-axis. So B is 3. Now from there, just like we did when calculating slope on a previous lesson, if we find another point somewhere on the line, we can count the slope. I'm going to pick this point right here, and therefore I'm going to count my slope, rise over run, from this point to this point. So rise 1, 2, 3, 4, and I run from there 1, 2, 3, 4, 5. So rise 4 and run 5. Rise 4 and run 5. And now all we need to do is put those two values for m and b into our equation. So y equals our m value, which is 4/5, and then we need the x there for sure, and then plus 3. So this is the equation for this line shown on the coordinate plane. Now, how about point-slope form? Well, point-slope form is y minus y1, sorry about that, equals m times x minus x1. So for point-slope form, as it sounds, we need to find a point, which is our x1, y1, and the slope for m. Now we already know from the previous example, the slope doesn't change of that line just because we're using a different form. So we still have 4/5. A point on the line, again, can be any point that we see. So I'm going to use the point right here, the red one that I plotted earlier, and that point, if we name it, is 5, right? 5, and then up to right here, 7. So that point is 5, 7. Now here's the thing with point-slope form. My answer might be different from everybody else's answer in the class, because if we all pick a different point on the line, we will all have a different equation. But each and every one of those equations would be graphed with the exact same line. So that's okay. So there's multiple answers for these questions. So if I have that point, 5, 7, I'm going to use those in for x1 and y1. Remember, when I put this in for x1 right here, if it's positive 5 in the point, it's going to be minus 5. And if it's positive 7 in our point, it's going to go in as minus 7. So we have y minus 7, the y value right here, equals the slope of m, which is 4/5, times x, and then this will be minus 5. Again, from right here, this positive 5 will go in and be x minus 5. So there is our equation for this line written in point-slope form. Okay, so now this example, something a little bit different kind of comes up here. And that is sometimes there's one form that is a better option than a different form. There's a form, either slope-intercept form or point-slope form, that is not a good idea to use right here. Which one do you think it is? Well, if you said slope-intercept form, you're right. Slope-intercept is not a good option for this purple line right here because this purple line does not run into the y-axis in the coordinate plane that we see. Now it will hit the y-axis. It will hit that. So if I continued this line down like this, at some point it will hit the y-axis. But we don't know where, and it would be an estimate down here. So not the best option. So instead of that, I'm going to go ahead and use only point-slope form in this situation. So go ahead, pause the video, and write the equation of this line in point-slope form. Okay, so here is the deal. If you pause the video as I asked and you wrote your equation, yours might be a little different than mine. And that is for two reasons. First of all, the point that I chose on this line was -2, -9. -2, -9. This is the point I chose. Now, if you picked any other point on this line, you're not going to have a +2 and a +9 here. Okay? But the second thing is our slopes. Now, my slope is -8, 3. Now, I was really careful to pick points that I thought were going through a whole number for x and y. You'll notice this point right here is pretty obviously at -5, -1. And then this point is at, like I said earlier, -2, -9. Now you might have thought that this point right here looks like it's right where an x and y grid line meet. But I would say kind of look closely or closer and realize that it doesn't really go through right through the center of that. Now if you had used down 3, right 1 for your slope, that's okay at this point. We can't be perfect when the line is kind of thick like it is, so we'll do our best, and sometimes that might be a reason that our slopes can be different on your, let's say, practice that you're doing versus an answer key. So keep communicating about that if you're wondering why our slopes or our points are different. But know that for sure our points are going to many times be different. If you had picked -5, -1, you'd have +5 and +1 right here. The slope usually should be about the same, but again, sometimes with the thickness of this purple line, we might have our answers affected a little bit. Okay, so what I'd like you to do on this last example here, and this is in your notes packet, I'd like you to go ahead and write the equation for the pink line and the blue line. We'll call this the pink line here, this the blue line. Okay, write those two equations in whichever form you feel more comfortable with or you think would be best for these, and then I would like to check those in class. All right, thanks.